Hello everyone, we're going to discover today how we can calculate forces and torques, aerodynamic forces and torques out of the results of a CFD simulation performed with console. Obviously, the first thing we have to do is open the .case file. We download it from the console platform. And in order to open that, we use PARAVIEw, which is an open source software available for everyone to download. In here I have the example of a simple impeller. I go to the very last time step with the fast forward button, and I just going to visualize the pressure inside of such impeller. Now that I have the results, I have first of all to extract the solid walls out of the mesh I downloaded from console. So I use the extract block filters available in PARAVIEW. So just extract block, and here I click the two surfaces, nose and wall, I want to extract from the solid mesh. As you can see, these two are surfaces. They are the solid walls of this particular impeller simulation. Okay, and once again, I can color them according to pressure. I can color them according to turbulence, and so on and so forth. So let's stick to pressure. Now we just have to do two operations which are compulsory in PARAVIEW. So just keep them in mind and just do it without too many questions, let's say. So we want, first of all, convert cell data to point data. We just click apply on this filter. And the second one is the extract surface option. So let's just do it, and without wondering why we do it, but we know it's mandatory if we use PARAVIEW in order to get the results we want to get. So now that we perform these operations, we are ready to calculate the normals of the cell's elements. These are fundamentals because the force applied from the fluid to the solid walls is made up by two different components. One is the pressure component, which is pressure times the area, and the second part is the wall shear stress. So we use another filter to calculate the normal, so generate surface normals. As you can see in PARAVIEW, everything is apply one filter after the other, and now that we have the normals, we can actually visualize them, for instance, in X, Y, and Z direction. But in PARAVIEW, I was saying, it's just a matter of learning the filters available and apply one after the other all these filters. Well, now we are ready to calculate the forces, so we click on the calculator button. We just call the output data as force, and we are ready. We are ready to calculate the forces. So the forces is obviously pressure times the normals plus the wall shear stress. Since we are using OpenFOAM as a CFD solver, and this is a non-compressible flow, we have to multiply everything by the density of the water, okay, in this case, because this is the impeller of a pump, so 1000. We just click apply, and now we have the force value to display. It's quite nice. We just want to integrate this value out of all the cells. So we use the integrate variables. We click apply once again, and this is the three force components in X, Y, and Z direction. Obviously, keep in mind this is just a slice. Probably we have to multiply everything by the number of slices the complete impeller is made by. Well, now that we know, now that we have this force, we can calculate the torque. So similar to what we did for the forces, we activate a calculator, we call it torque. And this times it's the cross product. So cross product between force, comma, and the distance of the force application point to our origin. So the origin is 0 times I hat, sorry, I made a mistake, I forgot the I hat plus 0 times J hat, I forgot the product, plus 0 times K hat. So the distance from the coordinate of the point we are currently using to apply the force. So 0 I hat, 0 J hat, 0 K hat minus chords, everything cross products by the force. So we click apply, and here it is. So this is the torque, to be honest, as you can see. Once again, we need to integrate everything across the solid walls in order to have the torque all over the impeller. As you can see, we have the Y component, which is predominant, and that's correct. Obviously, there is an X component as well, but this is averaged across, so it can be neglectable because there is another slice in the opposite direction. So this times the number of impeller is useful to calculate the total torque of the force. So with this, I complete the tutorial, and well, last bit probably useful for all of you. You can save your state, save state, whatever you want, and you can reload it with a new geometry if you want to calculate torque and forces on different geometries. Having said so, I thank you all for listening to this small webinar. Bye.